In this video, we want to explore a dataset and prepare the dataset for analysis. So we call this data preparation step that we need to do that in data science. We are using Jupyter Notebook. In the Jupyter Notebook, we have some menu for running Python commands, and we can create new notebook, open a file and copy, and edit cell, for example, copy cell, and there are other options that you can see here, and we have some icons here that we can run a command in Jupyter Notebook. But here the dataset that we selected is a music dataset. So let's explore the dataset and prepare that dataset for further analysis. First of all, we should import some libraries. These are prepared libraries by Python. We just need to import the library for analysis. Some of these libraries are for data preparation. Some of them are for visualizations like Seaborn, Matplotlib, and some of them are for data analysis and calculations like NumPy. We run this using control enter, or we can use run here to run this command. It simply runs these lines and import those libraries inside of our program. If we need additional let's say library, we can import it, and as you can see we use as and this is an let's say nickname or aliases that we can use to simply import the functions of the libraries. For example, PD for pandas, SNS for Seaborn, PLT for Matplotlib. And if we need to import a library that does not exist in Python, we can use pip install here to let's say import the libraries, right? For example, for Seaborn, we know that Seaborn is already installed in the program, but just in case we can do that as well. I comment this line as well, so we can use the control sharp or command sharp to comment a line, right? Yes, so we can add additional libraries inside of Python. Then we can load our data set. Most of the data set that we use in data science is they are in CSV file. For example, I have a data set named music messy, and that's CSV. It means that is a kind of data set which we want to clean it, right? And this is the encoding of that data set. Inside of that data set there are some records. We use the standard format UTF-8 to read the data from the data set, and this is the path to this data set. Here it says that in the current folder that I'm running this Jupyter Notebook, we don't have any music data set, but in the upper folder we have a dataset folder. Inside of that folder we have a dataset named music messy, and the extension is CSV. So I run it, and it doesn't say anything, it doesn't give me an error, so it seems all in good. So we can proceed to see the data set, and as you can see, these are the column of the data set. We have ID, title, artist, language, country, top genre, year, and all these columns or features of every song. So this is a data set regarding music, song, and the artist, and the other specification regarding that song, right? And it shows there are 606 rows, and there are 70 columns. Another thing that we can use, for example, here I can create another comment here, and using the dataset name, which we call music, we can see the shape of data, right? And we get the same values here. As you can see, 606 rows, and we have 17 columns, right? I mentioned about that how we can install library in Jupyter Notebook. So I can remove this cell. We have this here, and let's explore the dataset further. So like I said, we can see the contents of the dataset, and as you can see, there are some dots here between the records. It shows that we have more records between these records. It shows top 5 and bottom 5 records in the dataset. We can see the list of columns of this dataset using list, and as you can see here, we can see the list of fields. I think you can do another thing to see the list of columns. I think I can use music columns. It should give me the list of columns and that we have, and the data type of these columns. For example, if we want to see the data type of these columns, we can use the types. It should give us the data type, and as you can see, ID is integer, year, and all the other numerical columns are integer, and we have some object. It means that the data type is not clear. Most probably they are string. Review the numerical columns of this data set. We have music, and we use describe. So using describe, we can get information based on some metrics. For example, count of the records, mean value, standard deviation, minimum value of that column, maximum value, and 25 percentile, 50 percentile, and 75 percentile. It gives us some ideas about the numerical value. Obviously, ID is a kind of identifier, so we are not interested to get some calculations on top of that. But here we can see the music information that we have starts from 2010, and the latest record, I mean, in terms of year, it will be 2019. So the songs belong to this time period, 2010 to 2019. And we can see different features and different factors here, and somehow using the maximum number and standard deviation with one table, we can see if there are, for example, some outliers or not. For example, when we have the mean value 6, but we have some values like maximum 99, so might be there are some outliers, for example. So using describe, you can explore the numerical values of your data set, right? And there is another function named value counts that you can see the number of values in each column. For example, in the language, if I'm not wrong, yes, we have a language column, and we want to see the language of this song, and using value counts, we can see this column, and we can see that there is only one value in this column, which is English, and there are 606 records. Because our data set includes 606 records, it seems that all the songs that we have are in English language. So we can drop this column because it's useless, right? So in the data cleaning step, we want to go through the data set, clean the data set, and prepare it for the analysis. So regarding a useless column, we realize that, for example, language is useless, so we can drop the column as well. So we want to drop the column. We can use drop. For example, I want to drop a language. I say music drop language, and here we want to say that we are working on the column, and we want to see the results applied to the data frame, right? So that we don't see language column in music, right? So, and when we run it again, we don't have any error, but when we have the music, we shouldn't music data set, we shouldn't see the language column here. So we drop that because we didn't need that, right? And we want to do some cleaning. For example, in the title, if there are null values, we can fill that null values using let's say an empty row, right? Something that we don't have that. So for example, if that a specific column in title we don't have any value or it's null, then we can simply replace the null using an empty values. Here we can say from the music, go to the column title, use fill null, and here all the null values will be empty, right? And the results will apply to the actual data set, right? The same for DB. For example, for DB column, we want to see if there are some nulls, just add 0. Actually, title is a kind of a string, that's why we don't put here 0, because that's a string. But here DB is integer, that's why the null value will be replaced by 0, right? So again, I run it, and if I have an empty values or null values, we just simply put an empty string there, right? Another thing is, for example, in title, let's see the music content as well. As you can see, some of these title they are title case, right? They have a capital letter in the beginning, but some of them don't, right? What we want to do, we want to unify this artist name so that we can see unified value, because we want to do analysis on top of this column as well. What we can do here, we can use for example str and title, and we can convert those ones that have the small letter at the beginning to a capital letter, so that we can see them as title case, right? So if I do this line and run this line, I should be able to see that, okay, now I have here a title case for the artist. I can do the same, for example, if I want to convert it to a lowercase, it should be able to do that. And as you can see, the title is now lowercase, and uppercase should work as well. So here we can see that all the artist words are in uppercase. For now, I just leave it as a title case, and this is one of the things that we can do. Another thing is we can see that in the country we have some strange values, for example null. We can do the same. Let me see if we have null values. For example, we have nan here, which shows this is the null values. I do the same. For example, here I would say that for the country, fill it empty, or I would like to fill it as unknown. It means that we don't know that, right? So see this column, and here if we change it to unknown, we should see unknown here, right? All the null values are converted to unknown. But let's see what we have in country. we learned that we can use value count. So use value count and values count or value counts, which one? Yeah, value counts, and we can see that United States has 300 records and 30, United Kingdom, Canada, unknown, and there are some other countries. And oh, we can see that here we have United States of America and USA. So we can see some inconsistency in our data set. We want to unify them. Are there any other issues? Not for now. We have 0 as 1 as well. So we would like to have that 0 as unknown. What else? Okay, let's convert all the United USA and United States of America as United States, because United States has most records in the data set. So to use that, we can use NumPy library, and we can say NumPy, hey, where you see USA converted to United States, right? So this is the command that we use to convert USA to United States. So I run it, and if I run the value of k, I shouldn't see USA, yes. And I want to do the same, for example, United States of America, and I want to remove that, or and as you can see now, we can see more values in United States. And what else? And we have 0, and I would like to convert that 0. Let's see if it works in this way as unknown. Let's see if it works or not. 5 records 0. Now we can see unknown, more values, right? I don't see any other issues in countries, so we all good. And there might be some cases that we can see special characters in our data set. For example, here using a column, using a comment name replace, we can replace the value for a specific column. For example, this is the column, and we use str replace. All the string functions applies to str function here. So music artist replace a value by a value. For example, if you find this specific character, we want to just remove that. Sometimes in our data set we have special characters at the end of the word, sometimes at the beginning of the word, but in any case we want to say that if for any reason we see a percentage in our data set in the artist column, we want to remove that. So we can do that as well, so that we don't see that specific characters, right? Another thing that we can do, so you can do for all the columns, right? If you find special characters, if you find inconsistency, then you can resolve the issue using replace, right? Another thing that you can do is you can list the duplicate records, check if your dataset has duplicate or not. So if you have some duplicates, you can remove that. Music, the duplicated, is a function that we use, and we want to say that from music data frame, anything that is duplicated, I consider as duplicate records. You see that, okay, I found 3 records in my data set that those are considered as duplicate, means that these are exactly the same as other rows in my data set. So we had 606 records, and I want to drop those rows. When I drop those rows, then the number of records that I have will be less, right? So if I have let's say shape, if I have that shape, and we don't need parentheses, and we can see 606, right? And 16 columns because we drop one of those columns, right? So this is one of the things that we can do to drop the duplicates. Another thing that we can do is we can see the data type, and for example, for title or a string or country or top genre even, those are the columns that are in a string format. So we can let's say convert the data type to str or a string, right? Or we find, for example, a strange object, let's say data type, and then we can go through the columns and see that what's going on. For example, for year, if we have an string value in one of the records, we can find it, we can remove it, or we can replace it by a numeric value, and then we can convert the data type to integer. Here everything looks fine. We don't see a string, for example, for numeric value. In some cases, for example, you want to split one column to 3 columns. For example, artist, we have artist name, but we want to split the artist to first name and last name. One thing that we can do, we can use this command, artist str split, say that by comma or by a space. It depends that how the word has been separated. So we can see here the number of the words that we want to get from that word, and we want to expand it to artist name. So using this command, I split one value here into 2 values. Example, if the name of the name of the artist is Lady Gaga, right? We split this word into 2 words, and it has a space between that, right? The first name will be in the first name of the data frame, and the second array, the second element of the array, which is the last name, will be on last name. So we will add 2 different columns, and we place the first name in the first column and the last name in the last column. Let me do that. I didn't want to do that, but let's do that and see that if it works or not. So we have music. We should be able to see the first name and last name, and as you can see, we can see first name and last name here, right? Sometimes it works, sometimes not, but this is how we can split one column and to those to different columns, right? These are not errors. These are just saying that, for example, this function is deprecated and suggest to all use another function, right? Okay, so we have our data set almost clean, but we would like to create some features, right? It means that we want to add some columns. To do that, we can see we have BPM and energy. Let's assume that we want to create another feature based on BPM and energy, and we call it BPM energy, right? To add another columns in Python, we can use apply, and here lambda means that it's an inline function, and we can say that for each record, right, divide the BPM over energy, and we know that sometimes energy is 0, so we don't want to divide the BPM over 0. That's why we say that every time that it's not 0, right, divide BPM by energy, but if you find it 0, just place 0, right? This is how we work, right? On the columns, we want to do this kind of operations. So using these operations and say line columns, we can create new column names BPM energy, and hopefully it works. I then tested it should work. When we see music, we should be able to see the last column, right? BPM energy, and as you can see, this is based on BPM over energy, right? So in this way, you can create new features or new columns for your data set. And if you don't want to see all the rows, you can, for example, say that limit the number of rows that you want using, for example, head. Limit didn't work, so perhaps head. It gives you type five records in the data set, right? What else? And let's assume that you want to see your data set using sort values. You can do that as well. Music, sort values, just sort based on BPM. We want to do it descendingly, and we want to get the head 15 records, right? So when we run it, when we see the BPM column, you can see that BPM has been sorted descendingly, right? And you can do it by other columns as well. For example, year, and you should be able to see the most recent songs in recent years, right? The other thing that we can do, we can use matplotlib to be using box plots. You can see the average value, the minimum, the maximum of the numerical value of numerical columns. For example, for dB, here I created a box plot that we can see the changes of dB over the year. We can do it for other columns as well. For example, for pop, we can see here, I use it pop here, and I can see the ratio of pop based on different years. I change it to pop, and as you can see, the changes of this specific ratio in 2010, and you can see the changes over the time using box plot, the minimum, maximum value, and median, right? And so we can have a customized column here to change it to anything that we want. For example, here I use pop, but I change it to energy. So if I change it to energy, I just need to change it in one place, so that I can, let's say, change it to any columns that I want to see the changes, right? Here I can see energy. If I change it to anything else, for example, let's say danceability, we can do that as well, and we can see the changes over the time. So with box plot, we can see the moving average along with the minimum, maximum, and different percentiles, right? And we can see the percentile as well for 50 percentile, for example, the mean value, the different quartiles, the maximum value visually. For example, for VPM, we can see the distribution or histogram of this value. For every single column, we can see that if they follow the normal distribution or not, using the hist function here. As you can see, we just used auto beans. We can change the bean to any other values. We also can use dist plot, distribution plot of Seaborn library, to see what's going on each column. For example, here for dB, we can see there is left along tail, and we can see the skew of the skewness of this column. We can do again for the other, let's say, columns as well, to see that to what extent they are they are following the normal distribution or not. And as you can see, this one has less skewness than the other one, the DB one. And then we can, let's say, normalize it and scale it and those kind of things, right? Regarding the BPM, we would like to see if BPM has an outlier or not. So we can calculate 25 percentile, 75 percentile, and calculate the interquartile. And then using a rule of thumb, we can say that if 1.5 times IQR plus the third quartile, there are possibilities that they will be outliers, right? Yeah, right. And obviously we can see some numbers here that are not 100% outliers, but this is the formula that we use to find outliers. There are other formulas regarding to identify outliers in a data set, but we can use interquartile and third quartile techniques, right? For example, if we have a set of values like ages, and we can create a data frame from them, and we can find 25 percentile, 75 percentile from this array. And we can obviously see that if we use interquartile, the 1.5 multiply the IQR, which is the interquartile, plus the 75 percentiles will be considered as outliers. And this number says that, okay, we have an outlier which is H, right? And like I said, having outlier does not mean that we should drop that row, but just pay attention to that specific row, right? For other columns, we can do the same, create histogram, and using bin we can see again this one, which is a val column and music data set, follows a normal distribution. For example, if I want to see if it has a skewness, or what is the skewness of this one, we can see it's close to normal distribution, right? Regarding other values, for example, the standard deviation of a column, we can use numpy. Numpy.std gives us the standard deviation of a column. Here it's 2.6. We can group by the music data set based on a specific column. For example, I want to see the average value of BPM and over the year. So I can use pandas library, and I can use pivot table. What it does, it creates a kind of pivot table for us. So in index is year, so we want to see the average value by year, and we group by year in our data set. The values is BPM. The aggregation function that we use is average value. So an average value here is the mean function of numpy, right? And we create a pivot table, then we reset the data set, right? And then we can create additional columns. Here we don't need to additional column, just so I want to show you that we can group by the data set by a column and get the average value. We can do the same with the summation, with count, for each column as well. We want to see number of, let's say, column, the number of songs per year, so in that case we can use count, right? Okay, so we can create different values for BPM and average. We can create kind of error bars to see the changes over the time. I would say this is one of the techniques that we can use to what's going on each year. Another technique would be the box plot that I mentioned to you. So using this graph, you can see what's going on, the minimum, the maximum value of of a specific column over the year. Depending the data set that you want to use, you might would like you would like to, if you would like to change to see the changes of the average over the time, you can use error bar. Regarding the skewness of the data set, we can use skew over the data frame and can see all the columns skewness, see that what's going on each data set. Or for example, you want to see the shape of the data set columns, you can use curtices, see that to what extent they are thin, they are fat, for example, in a data set. Again, you can see if there is a kind of long tail in the dataset or not. You can use other methods like other libraries like stats to find a minimum value, median value, or mode value, and calculate for each column and see that to what extent they are in line with the shape that you see. For example, if we see this is a speech, and as you can see in the speech, the median value that you get is less than mean value, right? In this way, we can see that it's not normally distributed, it's right skewed, and so we can use different techniques again to resolve the skewness issue, right? If you want to create one single box plot for one column, you can easily do that using matplotlib. Using matplotlib, you can create subplots, and then you can use box plot, and in the box plot you just need to call the columns that you want. For example, here is music and dance, right? Alternatively, you can use the Seaborn library. It has nicer visualization in terms of showing the minimum maximum value, and here, as you can see, we are going to see the minimum maximum value rate for BPM, right? We create matplotlib, we change the size of the graph, and here using boxplot, right, we call the music BPM column, right? And here, because we don't want to see outliers, we are just removing the values below 0 or equal 0, because if we remove that, we can see that we have outliers here, so we don't want to see outliers. That's why we can write here, just give us those values of BPM column and that are greater than 0. These are the setting of the box plot, right? We want to set the X label, Y label, we want to see a title on top of the chart and something like that, right? We can have a box plot again over the time for columns like year and BPM. And as you can see here, we can see the changes over the time. We can use the Seaborn box plot library to specify the column and the metric that we want. Here we use BPM and music dataset, and you can see BPM, how it changes over the time. Another thing is we want to normalize our data as well. Sometimes we don't see normal distribution in specific columns. For example, quantile plot is a visualization that can help us to understand if the column follows a normal distribution or not. For example, if those dots are close to the line or on the line, this shows normal distribution. But if we can see here, for example, the dots have distance from the line, and then we consider that is not normal. We can use, for example, some tests like Shapiro test. In this test, we can see that the sample of that columns or the records of that column follows a normal distribution or not. Obviously, we have seen that the DB column is a kind of a skewed column. For example, as you can see, it has left tail, and as you can see, the long tail that it has. That's a good example if we want to normalize this column. For example, we can use a log transform. Again, we can add a column to a music data set, and using a function, this function is just log10 transform, and we can use the absolute value of those columns, and we can create another column named db normalize. In this way, we can use the values that we have in db and convert it or normalize it based on log transform. Then when we have the new column, we can see the shape of that column as well, right, using the distribution plot. And as you can see here, it's more normalized version of db, and as you can see, the skewness of this new column is 0.95, which is close to 0, right? But this one is different. So as you can see, we normalized the db column, right? And if we want to see the new column on box plot, you can see it's much better than the previous box plot, right? The previous box plot was based on db column, but this one is based on db normalized column. So in this way, we are normalizing the column, and the new values will be between 0 and 1, obviously, depending on the different values, like outliers that we have. We might have different ranges. But this is one of the things that you can do for normalization. Another method that we can use for normalization is using pre-processing function from scikit-learn, where we can use min-max scaler to scale the values. For example, I created a data set including these values. These are the numeric values, and these are the columns that we have. And we create a data frame for that. It's just a kind of data frame based on the music data set, and using the min-max scaler from the pre-processing library, we use transformation to convert all these values to normal values to normal values, right? So if I run this command, instead of those values, you can see the values are close to each other in terms of the scaling. So we are converting all these values to a kind of normal values, right? And if you see the music data set for those values before normalization, you can see we have different values and different box plots, because they are far from each other, they are not normalized. But when we use let's say the normalized version of music data set, we can see the mean value of those columns are close to each other, right? So in this way, we can normalize our data. I'm not saying that that's the best way to normalize all of the columns once, but I'm saying that for columns, we can check one by one, and we can normalize it so that we can use it in our predictive analytics methods or machine learning methods. Another thing that you can use after normalization, you can check the values, the count of them, and their percentage in the data set. For example, we want to see what are the majority of the genres that we have in our data set. Here, using top genre column, we use value counts, and we want to normalize it, and we use the count of the values and we want to see top 5 genres and in their distributions or percentage in the data set. So as you can see, dance pop, 54% of the values it has in top genres. And we can use, for example, dummy variables to add columns to our data set. For example, here you can see I created a sub data set from the data set that we had, and we call it music dummy. And we want to create dummy variables for genres, right? So we have artist and year and BPM, and based on these three, or based on these two, for example, we want to see the distribution of the dummy variables, right? I remove BPM here. I just want to see the genres here, and as you can see here, for example, for each genre we can see 0 or 1, right? So we create a column for a specific value in that specific categorical column, right, which is top genres, and it has a new name now, right? Acoustic pop, Alaska pop, India, and something like that, right? And as you can see, some of them has one value, 1, and here it has 1, some of them 0. So we are creating a kind of dummy variables to our data set, right? Okay, so after this, you can, after this data preparation, when you normalize your data, check everything, remove incorrect values, then you can do your analysis. You can save your data set in another CSV file and do the analysis on top of that. Okay, hope it's helpful, and you can use this kind of methods in your data set to make it clean and prepared for machine learning.